All right, getting ready for tomorrow's quiz on graphing parabolas. You will have a sheet tomorrow similar to the one that I handed you in class that gives you some of the formulas for the directrix and the focus. So if that's one of the things you've been kind of freaking out about, don't panic. We'll have that there for you to be able to make things a little easier. Now on to business here. When we're sketching the graphs of these, one of the original things we want to do, especially if something's in vertex form like this, is go ahead and get the vertex first. And again, it's always the opposite of h and then my k value if it's set up like this. The opposite of what's in the parentheses and keep this. So that'll get me my first point. So there's my vertex. Okay, domain and range we'll get once we've got it sketched here. And then the max or min. I know this is going up and down because my a value is -1. And speaking of those values, hey, I've got my vertex. Again, at this point, I can do one of two things. I can either pop the graphing calculator up and say, okay, let me get my values in here. Graph it should be opening down. It is, okay. And again, as long as you have your vertex in the middle of your chart, you should see the symmetry that's involved. So -3, I'm at -2, same for -1. And at 0, I'm at -5, and the same of -4. Again, we want to get some curvature going here. Good. Okay. So as far as domain and range go, okay, domain and range. Domain, again, is my x values from left to right. Well, since these arrows are going to keep going forever and keep expanding, that would be infinite. My range, however, and be careful, it's bottom to top, would be from -infinity to my highest point here, which is at -1. And since it opens downward, my vertex is at a top point, which means my vertex in this case would be a maximum. So those are the types of information that we're looking for. Now, as we go along to this next one, same idea. Vertex is at 4, 2. I look and say, okay, let's see. This one's going to be opening upward. Well, since it opens upward, I know that's going to be a minimum before I even graph it. And when I go to do the rest of these, again, you have choices in the matter. If for some reason you don't like using the graphing calculator, hey, whatever works for you. You can take a couple values that are less and a couple values that are more. And again, the ones that are symmetrically as far away from my vertex are going to have equal values. So I've only got to do it for one of each of those. So let's say, for instance, I use 6. 6 minus 4 would be 2. 2 squared would be 4. 4 times 2 is 8, plus 2 is 10. So that would be for both of these. If I use 5, 5 minus 4 is 1. 1 squared is still 1. 1 times 2 is 2, plus 2 is 4. So you see, that might be just as quick for some of you, rather than trying to type all of this in all the time. Get those dotted. Get my curve on. And then again, my domain and range. Domain, typically, whenever you have a quadratic, unless it is opening sideways, will be infinite, -infinity to infinity. My range, this time a little bit different. The bottom is where I have the cutoff, and it's at my y value here of 2, but it goes up forever to infinity, and I'm good. That should be the simplest part of this. Now when we get down here to the bottom, things change up a little bit on us. And again, just to give you some comfort, tomorrow, when we're working on this, you're going to have a sheet like this available to you. Okay? And you're going to be able to have this to help you remembering your focus and directrix. So this will be available when you walk in the door to use in the quiz. Nice. So, with that in mind, we have our vertex still in our vertex form. So good things there. And then the focus and the directrix. Okay, so for my focus, if you remember back when it's not at our origin, my focus formula is going to be h k plus 1 over 4a. Okay, well, my vertex gives me my h and my k. So 2, negative 4 plus my a value is my value in front of my x squared term. In this case, in front of my parentheses, or my quantity. So 1 over 4 times negative 1/4. Kind of messy, but not too bad. 4 times negative 1/4 is negative 1. So this is negative 1. Negative 4 minus 1 is negative 5. So that would be my focus. And then my directrix, that expression is y equals k minus 1 over 4a. So, okay, y equals, my k value is negative 4 minus 1 over 4 times negative 1/4. So negative 4 plus 1. Because again, we saw before this reduces to 1, but now it's minus a negative here. Whereas here we had negative 4 plus negative 1, and we have negative 4 plus positive 1. And this goes back to our whole idea of these being equidistant as far as the y value to my vertex. If negative 4 is my vertex, negative 5 is 1 away, below it. Negative 4 to negative 3 is 1, above it. So when I go graph this, we'll be able to see this a little bit more with that equidistance. Oops, definitely don't want negative 25. That would be kind of a little bit off. So x minus 2, quantity squared minus 4. Bring up my chart, and again, to find that symmetry, get your vertex in the middle. There it is. So again, now I like to use the whole numbers. So 0, negative 5, 4, negative 5. Gets my curvature. And again, if I were to graph my focus, there it is. There's my directrix with my horizontal line at y equals negative 3. They're equidistant from my vertex on the y side, and that's what this is. So again, we'll kind of blow through these a little bit more here because we've got our information. Our a value is 1 if I don't see anything else. Oops, excuse me. I had the calculator in the way. Opposite and keep, so 5, 4 is my vertex. A little slap happy here in the afternoon. And again, it's going to be h k plus 1 over 4a. 4 plus 1/4 is 4 and 1/4 would be my focus. For my directrix, it's y equals k minus 1 over 4a. So 4 minus 1/4 is 3 3/4 for my y. And again, I'm just going to go with values because this one's easier than dealing with the fractions. So if I use 6, let's say, 6 minus 5 would be 1. 1 squared, so it'll be 1 plus 4 is 5. Gets both that are symmetrically the same. If I go to 7, let's say, 7 minus 5 is 2. 2 squared is 4. 4 plus 4 is 8. And I've got that in. Okay. And again, I'm just looking for the sketch of this graph. I did the focus and directrix over here just to let you see the equidistance. It's a little bit harder when the numbers are so close together. But sketching the graph, focus, directrix, vertex, we're good. When we get over to the back, from the equation of a parabola, how do you tell which way it'll open? Well, it depends on the a value. If it's positive, it's opening up. If it's negative, it's opening down. Same thing going with the max or a min. If your a value is positive, you're going to have a minimum. If your a value is negative, meaning it's opening down, you're going to have a maximum. So that a value tells us quite a bit about what's going on. So here at the end, identify the vertex axis symmetry and the x-intercepts of each, then sketch the graph. Okay. So here, To find my vertex, I'm actually going to find my x-intercepts first. Because remember, my form over here is x minus, I'm finding my intercepts through these, and it's opposites. So technically, it'd be the same as setting these equal to 0. So -3 and -1 are my intercepts. To find my vertex, I find the midpoint of that. Now in this case, I mean, we kind of know it's -2. But otherwise, to find that x value, you always can add those together and divide by 2 to find the x value of your vertex. Once I have that, to find y, I'm just going to go ahead and plug it back in here. So I've got -1, +1 would be -1 times 2 is -2. So my vertex is at -2, -2. And then my axis of symmetry always goes hand in hand with the x value of my vertex. So my axis of symmetry is at x equals -2. And that's how this will work. I know this one's going to open down. Okay. My intercepts are at -7 and -4. Now this time it's a little more interesting because it ends up not at a whole number or an integer value. -7 plus -4 is -11. Divided by 2 is -5.5. That's going to be the x value of my vertex. So then my y is plugging that -5.5 in there for each of those, and then just being really careful. So when I have 1.5 times -1.5 is -2.25, but then that negative is out here. So that's going to become positive, making my vertex quite interesting. -5.5, 2.25, opening down just like it's supposed to. My axis of symmetry is x equals -5.5 because it goes just like it's supposed to with the x value of my vertex. And finally, little work with this vertex x symmetry, but max or min. Remember, max, min. Ooh, yuck, you're going to have to figure out the vertex this time. You do. Remember, that's -b over 2a. So the opposite of -12 is +12. 2 times -1 is -2. So my x value is -6. Then when I plug that back in and work it through, you're going to have to trust me on this one. It's going to be -2. And again, at this point, when you know what those values are, you can just go to the calculator. You can just type this in and say, okay, -x squared minus 12x minus 38. And use your chart as long as your -6 is in the middle. And you can fill in the rest of your chart that way. Plot my points. Get those in. I see that it opens down, which means it has a max. I have a vertex at -6, -2. And my axis of symmetry, as always, just goes along with the x value of my vertex. And I apologize. I guess I had not erased some things. I am running out of room on my recorder, so I'm not going to be able to put number 9, but I will have that on this review that's online. So good luck with this, and we'll see you tomorrow.